Okay, we say that sine and cosine functions, or the graph of sine and cosine functions, are what we call periodic functions. And what that means is that they repeat. They just repeat. And you saw in the video that those waves just kept going and going and going, right? And so they means it repeats at regular intervals. Okay? And you saw how they could model real-world situations in the video, everything from tsunamis to energy to music. So they are important for us to understand. Now, a periodic function, like I said, repeats. They repeat in cycles. Right? So a period is the time it takes to complete one cycle. Okay? So the period is the time it takes to complete one cycle. And I know the video was pretty quick, but if you were watching closely, you saw that in fact they were changing the periods. They were using the piston. They had the piston that was going really fast, and then they slowed it down. They were affecting the period of it, so how long it takes to complete that one cycle. Okay? Is another new vocabulary word for you, which is the amplitude. Okay? The amplitude of a periodic function is defined to be 1/2 of the difference between the maximum and the minimum function values. They are referring to the maximum and minimum. You know how you had the waves, how it would peak, and then it would go down, and it would go down to a minimum, and how it popped itself back up, and it kept doing that. That's the minimum and the maximum. So, for example, let's just say I have a max at 3 and a min at -3. To find the amplitude of this particular function, periodic function, then what we would do is we would take our definition. Our definition is 1/2. So 1/2 times the difference of the max and the min. So I would take my 3, my max, and I would subtract, because that's different, so I would subtract my min, and in this case the min would be -3. So I have my double negative, so we would change that back to a plus positive. Thank you. And that would give me 1/2 of 6, which would be what? 3. And that would be my amplitude. So that's how you'll find your amplitude. All right, so let's see if I got my. So if we look at this, we started off with our first little cycle there, okay? So with that first cycle, we actually end up with that parent, okay? Now, the questions they asked, what is the domain? What are all the possible x values of this function? What's it doing as it goes to -infinity? What is it doing as it's going to positive infinity? What x values is it picking up? All of them, right? So it's waving to -infinity, it's waving to positive infinity, so the domain of your sine function is all reals, or you may have done an interval infinity. Okay. All right, what is the range? What is the range? We go from what value of y to what value? -1 to 1. So our range, okay, our range goes from that -1 to the +1. Right? And we are headed to -infinity here, and we're headed to positive infinity here. Okay? What is our amplitude? What did you find your amplitude to be on this one? 1. The amplitude was 1. And that's actually occurring, what's happening at that 1 and -1? What are those key points there? They asked you a question about minimum, didn't they? Down in the next couple of questions below it, they asked you about where's the minimum on this thing. The minimum between 0 and 2 pi was where? It was down here at that -1, right? So you can get some information from that amplitude, can't you? Right? And the period. What's the period? We talked about that earlier. That period is the time it takes to complete a cycle, and in this case, how long did it take to complete the cycle? 2 pi. Okay, so the cycle of 2 pi. Okay, so very important information for your parent sine function. Does this graph have asymptotes? Yes or no? Given this domain and range, domain, infinity, range between -1 and 1, are there values within this range where this doesn't exist? Where does it not exist?
Outside the box.
No, but if we stay within our domain and range, is there an asymptote within this domain and range? No, there's no asymptotes, because we're kind of restricting the little snapshot that we look at. Okay, so we talked about the minimum. The minimum value is down here at -1. Kind of lines up with your amplitude, right? Kind of lines up, and that was occurring at 3 pi over 2. Okay. On E, they had you look at 3 values. All those values ended up being what? 1. Why is that? Because they were all coterminal. They all ended up where? Did they all end up at 90? Okay. Then they asked you, is the graph symmetric about the y-axis? So let's look. So here's our y-axis. Is it symmetric about the y-axis? Yes or no? No, it is not. Okay. Does it have symmetry somewhere else? It does have symmetry in the origin. You're right. How do we see that? So if we did what? If we took this right here and we rotated it, you see it's going to the origin. If we rotate that 180 degrees, is it going to end up on top of the other side here? Yes. Is it going to mimic over here? Yes. So it does have symmetry about the origin. Do you remember what we call the functions that are symmetric about the origin? Do you remember what we call those? We had 2 kinds. All right. So if this is symmetric about the origin, what is this type of function? Symmetric about the origin. It is which one? Odd. So this is your odd. It is odd because it is symmetric about the origin. Yes. Okay. All right, so we've got a lot of information now for our parent sine. We know the domain, we know the range. We know it does not have any asymptotes. We know that, we just talked about it, that it's odd, and that will pop back up a little bit later. It's really important, so make sure you mark that down. What else? We talked about the amplitude and the period of the sine. Any questions on your sine? Okay. So the last thing is, let's look at where it's increasing and where it's decreasing, just to kind of get a little better handle on this. So we would say it's increasing where? Could we say it's increasing from -pi/2 to what? What interval would that be increasing at? If we're at -pi/2, where is this thing increasing up to? Where is it increasing? Where does it stop increasing? At pi/2. So we have some increase here at that interval. Where else does it increase? The 3pi/2, and it goes up to that 5pi/2. So there's your intervals where it increases. Where does it decrease? Well, here. Okay, so over here, the negative 3 pi over 2 down to the negative pi over 2. We have a decrease. Somewhere else. Yeah, let's go back over to this one. Yeah, we'll have a decrease there as well. That pi over 2 down to the 3 pi over 2. Yes, and we'll have a decrease over here as well. Yeah, we're off the grid there. Okay, so we're having the increase and decrease. We're having a bit, essentially turning points, right? And we're having those max and mins occur in there. Okay. Okay, so I've plotted here some of those points. I'm going to go ahead now and connect them so we can kind of see what. So from 0 to 2 pi, what is he shaped like? What was kind of like a U or something? And then if we, and I'm going to go ahead now, and I'm going to go over here to the negative side. Don't make fun. It's hard to do on this thing. Okay? Sorry. We have a little extra curve down there, don't we? Sorry. All right, so let's look at the parent. From 0 to 2 pi, I'm going to highlight him. So from 0 to 2 pi, here is our parent. Okay? So let's talk about the properties of him real quick. So what is the domain? Again, the domain is all real, right? We're headed to negative infinity here. And here we're headed to our positive infinity. What about our range? Our range, again, is negative 1 to, whoops, that's not, negative 1 to 1. Okay, what is our amplitude? Our amplitude is 1, right? So I'll write that down there because we can see that. Now, what is the period of the cosine? It is also 2 pi, okay? So they share a lot of the properties, but they look a little different, don't they? What would happen if I took this here and I moved it and I shifted it to the left? What would it look like if I shifted it to the left? Would it look like the sine function then? Because doesn't sine start at 0? So cosine is really essentially just a shift, just basically a horizontal shift of your sine function. Okay, so that's that's why their domain, range, amplitude, and period are the same. Okay, all right. So let's answer our questions. Identify the interval on 0 to 2 pi for which the cosine function is increasing. So where was this thing increasing at? Yeah. Okay. Over here from negative pi to 0, and then over here from pi to 2 pi. Okay. The symmetry. What's the symmetry of this one? Is this one symmetric over the y-axis? Yeah, it sure is. Is it symmetric? Does the left and right match? Yes. So we would consider this to be what type of function? So this one is our even. It is symmetric about the y-axis. Therefore, it is even. Okay? Is that our last question? Oh, and we talked about the relationship between the cosine and the sine. That cosine is really they're just kind of shifts.